Okay, welcome to the second session. Uh, See, anyone would like to go fast forward? I think there are recordings available for the first batch. I mean, first batch means not the first batch, but previous batch. It is properly recorded. Uh, Please let me know. I will give access to that. You can also attend live sessions as well as you can also attend you want to go with a fast forward pace, I think you can go to that videos as well. Almost, I think 35, 36 videos are there. Uh, it came to an end that session. Another two, three sessions are there that you can go through if you want to go ahead with fast forward pace. So this learning is kind of a steep learning. It takes little time, an hour, and assume approximately 1 hour 15 minutes we are going to spend. I think 60, 75 minutes, 80 minutes we are going to learn. So, yeah. So, if you want, if many of you agree that on Saturday we can go for 2, 3 hour session as well, that we can do. We can split into 2, 3 hours in order to improve fast pace. Okay. So coming to the session, yesterday's first session, day before yesterday, we just understand uh, how to create a basic application, and we also understand the feature something like what we call it as a cross compilation. We call it as a cross compilation. How do you do? Look at it. How do you do the cross compilation? How to create a basic application using Golang? How to do the cross compilation? These kind of things we discussed. Okay. Basic features of Golang as well. What are the very basic features of Golang? We have discussed. Okay. So this session we will go to the next step. Again, as I said earlier, instead of explaining the features and stuff like that, we will focus more on the applications. We start writing very simple applications. No, not necessarily to be very big applications. We start with very simple applications. We learn through applications, and then in between, we'll learn about the uh, variable declarations, where things get stored, etc. These kind of things we'll do. So go back to the next one. So there is already, I would like to create something called stub so that I'll always copy from the stub. So mkdir stub. Stub is something that I would like to always copy from the stub. Stub, that's main.go. So you can go to the main.go, package main, function main, and I'm already inside the stub, so I do go mod init demo. That means I'm going to create demo every of the examples unless until we are going to create a separate package or something. So for any example that we create, which contains actually main as the demo name, sorry, module name, main as the module name. This module is very important, as I said earlier. This is the very important first step of your project, in fact. But right now you may not be aware of it, but going forward you would be aware of it. So this is the very basic construct. So what I do here is from here onwards, every example I copy stuff to the another project so that readily another project is available for me. That's what I mean to say. and then I start writing code so that it's very easy for me. So now we start with variable declaration. Variable declaration is not just variable declaration. You need to understand many things along with variable declaration because it's not just declaring some variables. There is much more important things are there with respect to variables. We will discuss about that along with the variable declaration. Okay. First, I'll tell you what kind of variables you can declare. We can declare constants. We call them as const is the keyword. Constants are the variables which once you assign some value, you can never change. You don't change the values, which we also call it as immutable variables. Immutability is not separately there in Golang like Rust. Uh, even I think JavaScript has immutability is there nowadays. You create a constant or you create a you variable using let, okay, or you create variable using var, something like that in JavaScript. Okay. But in Go, immutability is nothing but if you create any variable with a const, that is nothing but immutable. Immutable means you cannot change the value. You cannot mutate the value, right? Which we call it as a constant. Okay, which is called immutable. So what can I do is I can put const, maybe pi, what type that the variable is, type of the variable, type of the variable, which we call it as a data type. Types of the variables generally there are a couple of types. Okay, generally we have numbers, numbers in the sense the real numbers. So we can have something like integer, which is uint. Integer means the size of the integer is based on what architecture your system is. If it is 64-bit architecture, the size of the integer is, if it is a 64-bit architecture, the size of the integer is 8 byte. Okay. It is a 32-bit architecture, the size of the integer is 4 byte. Okay, there is an integer. So it depends on what variable, what architecture you are running. I think 99.9% computers are 64-bit. So we can assume that the size of the integer is 8 bytes, but actually it is not. So uint 8, int 8, and then uint 8, signed, unsigned, and signed integer 8. Unsigned means you give only positive values from 0 to 255. Signed means, sorry, signed means, yeah, you don't specially tell signed, but you can give negative values and positive values. That means 8 bits are split into minus negative value and positive value. That is where we call it as signed. Similarly, I have int 16, uint 16, int 32, uint 32, int 64, uint 64. There is float 32, float 64. These are the types. We can think of these are the types. Other than this, integer has some kind of a alias types. Alias types are not really types, but they gave a different name to the same type, which is called Rune. I will discuss about it. Byte. These are not real types, but these are the types for the existing type names. So Rune is nothing but int 32. Byte is nothing but uint 8. These are called the number types. These are all the numbers, whether they are the positive or negative numbers. Okay, they are the whole numbers, they are real numbers. You get it in the decimal points, everything. These are all the number types. That means any number you use in Go, most probably, along with it should be with this particular type. Okay, let me see. Anything that you write in Go, okay, most probably the number will be this particular type. Okay. Those are the number types. So, yeah, no, wait. We will discuss. We will discuss later. Okay. I'm just maintaining. I didn't even discuss about this. We will discuss one after the other. Okay. Everything we will discuss in an order. Okay. For sure, we will discuss. Okay. These are called the number types. So the next one is because once I start with this, we will not even discuss about this. So after discussing this, we will discuss this. So the next type is byte. Byte is sorry. Next type is boolean. Boolean is there is only one thing that is called bool, which is going to give you true or false. The next type is string, which is nothing but okay collection of characters. Sorry, collection of bytes. String is nothing but collection of bytes. Collection of bytes is nothing but general string. Generally, string in Go we don't consider as collection of characters. We consider it as collection of bytes. Okay, we would be having the collection of bytes, which we call it as a string. So collection of bytes like any string we talk about. And there is a special type, okay, which is we have to discuss a lot about that particular type. Basically, string and that special type both we need to discuss quite more about that particular type, which is called empty interface. We call it as interface type, which is empty interface or anything you can use with empty interface or any. Okay. Anything we can think of it as empty interface. Both of them are same. Both of them are same. If you go here, this one and Rune, both of them are same. Just the name is different. Here you see uint 8 and byte, both of them are same. It's just the name is different. Convention purpose, we use the name, different name, but actually 100% both of them are same. We will start declaring that and then we will reach there. We will discuss about this. So I'm going to start with a constant which is called immutable. So what I do is constant ply is float 32. The type of the constant which is called pi, let me give it in a capital letter, equal to float 32 equal to 3.14. What does it mean is, okay, we create a variable called pi, which is a constant variable. That means the variable is has never be once assigned, the variable would never be changed. The value would never be changed, which we call it as a constant. So constant you can create as a local variable. That means if I say print line, okay, constant pi equal to pi. This is the variable because you cannot right now you're not reassigning the value. You cannot do that because it's a constant and it is declared here, which is a local declaration. That means the pi can only be used inside this particular main function. As I told yesterday, this is called, it creates a stack frame. Every function that you create, it creates a stack frame. Within the main function, we declare a variable, okay, within the main function. This is how it is declared. Let us say that I want to use this variable. So, for example, pi multiplied by, for example, we create a function. Okay, I would like to multiply by 2, let's say, even it's again a simple function. I want to take pi, so I want to say print line pi into 2, for example. I want to do that. pi into 2, you cannot do that because it is declared within the function. So it has to be declared outside of the function so that it can be used, it can be accessed by any function directly in the main, so that generally constants are declared outside of the function. What would happen? They are declared as constants. What would happen when you declare inside the function, outside the function? That also we will discuss going forward. Okay. So this is what actually the declaration of the constant. Basic declaration of the constant. We will discuss more about it. How do you really mutate a constant? Can you mutate the constant? What would happen? How can it work? What are the rules that you need to follow in order to mutate a constant? We will discuss about it going forward. Let's go with this. Generally, you cannot mutate the constant at runtime, but there are some ways you can mutate the constant at compile time. Compile time means until you compile your application or during your compilation. Runtime means once you compile your application, okay, it is in a running state that the values would be assigned when you run your application, which we call it as a runtime. There is a clear distinguish between a difference between the compile time and the runtime that we in the previous session I just gave you some kind of idea, but that also you will understand going forward. Okay, so this is the variable. This is a constant. You can create constants like with different variables. Okay, different data types as well. So we will come back to the constants little later, but right now let's go with the normal variables. I want to assign a value. I want to assign a value. You need to create a variable. Okay, how do you create a variable in Go is there are a couple of ways to create a variable and assign a value. But you can create a variable but to begin with where maybe num1 is integer, is a variable. In Go, once you create a local variable, okay, this is called as a local variable. Why it is called as a local variable? This variable can only be used within this function. You cannot use this variable outside of the function. Whenever you create a local variable in Go, that variable must be used. If you don't use that particular variable, what would happen? If you don't use the variable, what would happen? You get a compile error. The compiler would not accept you to compile. So if I say go run, okay, the compiler is saying that declared and not used in num1. So you must use the variable. That is the first one. Once declared, it must be used. That is the first one. Second thing is every variable in Go has got a zero value. We call it as a zero value. Zero value is a terminology. Okay, zero value is not always the value called zero. Zero value is a terminology. It depends on data type and that you are using in Go. For example, if I print number, it is num1. It prints the zero value. It prints the zero value means basically based on the type of the variable. Based on the type, all numbers, the zero value is zero. The Boolean, the zero value is false. String, the zero value is empty string. Interface, the zero value is nil. So nil we will discuss. There is a zero value for each and every variable. So that ensure that your compiler is not going to give the garbage values and your compiler would not force you to assign a value. Some programming languages, particularly the Rust, Go, I think Java, old version of Java, I don't think no version, old version of Java, and all, they enforce you that declared and not assigned something kind of error. You have to assign a value to the variable. Rust also compiles. It doesn't let you do just to declare a variable because there is no concept of zero values and all. This, I think this is also called as a, value inference. It infers a value. We call it as a zero value or value inference. It infers a value whenever you declare a variable. Similarly, if I create, so here we have not assigned any value. This is a variable. Obviously, this is mutable, so I can mutate to a new value. I can mutate to a new value. This is mutable. Why I'm talking about mutability? Because you may think that it's pretty natural. You declare a variable and mutate a value. Because some programming languages, mutability is while creating the variable itself, you should tell that whether it is mutable or not. So if you ever gone through such a programming languages, you understand how important the mutability is. Mutability is very important actually. But it is a auto mutability when you declare a variable, but not the constant. When you declare a variable, it is mutable, so it is no surprise. There is nothing surprise that okay, the value that you can assign. There is nothing like a surprise thing. The next thing is we go step by step. The next thing is you can also create a variable, give the type, and assign a value. You can also create a variable, give the type, and assign a value. So this is also instead of taking zero value, you are directly assigning a value while creating the variable. Okay, you can mutate it whenever you want. You can go and then change the variable. Again, there is nothing big in that, but you can assign a value while creating a variable. You can create a variable. You can create multiple variables, which we call it as a group of variables. Okay, you can create a group of variables. Let's say uint 16. Let's say int 32. Let's say int 64. You can create group of variables. Sorry, you don't need to give the and assign values and assign values. You can create variables and assign values directly, or you can create variable and don't assign a value. That's fine. Automatically the zero value is taken. So I created four variables, which we call it as a group of variables. Not necessarily to be the same type. You can also create the Boolean type. This is a default value. Zero value is false. So here zero value, it is false. You can also create a string. You can give hello world. You can give like this. You see that these are all the variables at a time you declare using var. Obviously, you have to use them, otherwise the compiler would give you an error. So far what we are using print line, which is the built-in function from the built-in package. You don't need to include that particular package, import that particular package, but we are planning to print using formatted printing, which is called as a formatted printing. If you want to use the formatted printing, you have to use fmt dot println. Probably number 3 is number 3, comma number 4 is number 4. You can just give the string followed by the comma, and then you can print any number of values. Number 6, I just want to print the text, and then number 6, maybe OK1, which is I just gave it as a boolean as OK1, and then str1. It's going to be the str1. So FMT is what? Actually, FMT is a format package. which is used as a formatter, which can be used as a print the things according to whatever the format you want, etc. This is called as a formatter. Format FMT is a package. The moment you use the package, you have to import the package. Here, Go tooling is actually helping to include this particular package. Go tooling is helping to include this particular package. Otherwise, you have to manually go and then include. So, what is called Go tooling? Whenever you install Go, one thing you need to understand is to install a couple of tools as well. Okay, one of the tools is you go to the extensions, you see Go. When you type Go, you can say rich Go language support. This is very important. This has to be installed. The extension. I hope you are using Visual Studio Code or Codium. I am using Codium. Code and Codium, both of them are for the same Visual Studio. The code project. Okay, I used Codium because code is pretty slow for me. Might be Microsoft is using some kind of a telemetry data to improve it, but I don't want to do that. I want a quite speed code editor or IDE, whatever you call it as. Generally, it is code editor. So I'm using Codium, not the Visual Studio Code. Same branch, same open source, but a different uh, offerings. It's a pure open source. Visual Studio Code is also open source, but the thing is that Microsoft would add some more tools to that. Some agents would be running, some tools would be running, and keep on trying to connect to the Microsoft bundle. I feel like it's quite slow, so I used Codium instead of the code. So this is the extension to be used. This is very important extension. Other than this extension, what you need to do is you need to install a couple of tools that would help you. How do you get the color coding? How do you get the help? How do you get whenever we say FMT dot? These are from the language server. Okay, static code analysis, Go Pulse, like that. There are, I think, five tools are there. Earlier it was 11. 11 got merged into seven. I think those seven tools got merged into five separate tools. These tools to be installed on your machine. How do you install those tools? Is you go to command palette. In the command palette, you need to type go, I think update, install or update tools. I mean, it is not even five, it is only four. Earlier it was five. It started with 11, 11 became seven, seven became five, now five became four. It may be five for you. It depends on which version of Go you are using. You need to select all of them. Okay, the thing is that IMPL is a implementation for Golang. IMPL blocks, we call it as its implementation block. It creates stubs for the interfaces, etc. Go Playground, which is maybe required, may not be required. Go Playground is a language playground where you can write applications on the fly, like in a web interface. DLV is a debugger. If you want to debug Go applications, you need DLV. Go Pulse is a language server. This particular server would keep on assisting you. Okay, whenever you write something in this particular editor. Okay, these tools to be installed. So how do you get the tools? Go, sorry, how do you get the tools? You go to command palette and install or update something like that. When you type it, automatically you select all of them. You say install. They are all installed using a command called go install. I will also discuss about that command while we are talking about the uh, go build, go run and all. I will also talk about that, how this particular go install work. Okay, let me copy this for some other purpose. Sorry, not this one. Okay, these tools to be installed in your system. Then only everything like how it is working in my computer, it will also work in your computer. Okay. We will discuss about how to install them separately, how what is called go install does and all separately. Let's focus back onto this. Okay, these are all the variables, basic variables. You have used a formatter in order to print all these variables. I simply say go run dot. You know that dot means picks all the variables. No need to give make dot go. It would go and then print all the values and variables. I'll also give something like probably I give float 1 is float 32, so equal to some value. Float 2, which is called float 64, which is also some value. Okay, these two variables are showing error because we have not yet used them. So after num6, okay, I give float 1. It's just a variable name, nothing else. Float 1 is float 1 and float 2 is float 2 comma okay comma okay 1 might be given float 64 float 2. These are all the variables that we have declared using Go. These are all the variables. We need to discuss about other variables as well. We will discuss a little later. Okay, these are the variables. So where all these variables are created, remember that all these variables are created within main. So these are not called as a global variables. These are the variables those are created within main function. So these variables are local to the main, the way how we also declared earlier a constant which is local to main, a constant which is local to main. Okay, we also declare the variables within main. Fine. A lot of discussion because this is the core part of not only Go, any programming language. You need to go. It looks pretty silly, but you need to go a little bit of deep understanding of this. It is required. Okay, fine. Go to the next step. In Go, what happened is there is a concept called type inference. Type inference means you can directly assign a value to a variable. Let's say that where maybe num6, I give num7 equal to some value, where num8 equal to some value, where float3 equal to some value. You see that there are three variables. I did not give any kind of type of the variable. If you don't give the type of a variable in Go, what it does is it does the type inference. Type inference means if I give where OK2 equal to true, if I give where str2 equal to hello Golang folks, like this, if I give like this, these variables, automatically based on the right hand side value, which is assigned, the type is inferred to the variable, which we call it as a type inference. Type inference means sometimes you don't need to give the type of a variable, but automatically the type is inferred to the variable. You don't need to give the type of the variable, but the type is inferred to the variable, which happens automatically by the Go compiler. Go compiler does that. Who does that? Go compiler. Type inference. So whenever you infer the type of a variable, obviously whether you infer the type, you don't infer the type, or the compiler infer the type, if you create a variable, you must use the variable. So again, what I do is, okay, sometimes type inference also you can create group of the variables. You don't need to always give every variable as a type. You can still do the type group of variables. See, these declared individually, these declared as a group of variables. But one thing is you must use them. Earlier we used them using fmt.println. Now we go to the formatted printing. Formatted printing means fmt. Uh, this is everything is a formatted printing, but fmt dot with a specifier print f, which is a we need to tell the specifiers. You know about C language, there is a format specifiers, percentage %d for decimal, percentage %f for floating point, percentage %s for string, etc. There are certain things we can also give that. So what I do is percentage. So let's say number 7 colon percentage %d. This is going to be substituted there. Number 8, which is going to be percentage %d again, and then float 3, I can give percentage %f, but I just want, let us say that I want to give the very big decimal point number. Okay, I give very big decimal point number, but not only the float value, but also I would tell that I want only 3 decimals in the float. I want only 3 decimals in the float. Like this, you have to use the format specifier. I can use OK2. I think the format specifier is V, is a value, any type of value you can use. So for OK2, you can give V, str2, which is percentage yes, which is got to be the string. And I said fmt.printf, it is not going to write in a new line. So slash n is going to return it to the new line. So number 7, number 8, float 3, OK2, and str2. These are going to be replaced. These values are formatted and then replaced over here. Percentage %d means decimal. Percentage %f means floating point, but you can control the how many digits you want in the floating. It's a very big floating point number. Okay, it, I just want to control only 2 digits or 3 digits of that particular floating point. I don't want to give everything whatever comes here. I want to give only 3 digits, so you can always give 3 digits. Again, it would not seal it, it would not round it, such kind of things it doesn't do automatically. Okay, it is just sealing and rounding is the different functions, right? You round it means it's more than point after point, it's more than 5. It rounds to the next number, less than 5, it round to the previous number, something like that. For example, it is 6.67 or something, it would just put it as 0.700, something like that. That doesn't happen. This is just, controlling or formatting only to number of digits that you want to give. This is how you can create a variable. How you can create a variable. You see that only 3 digits are given with a type inference. So the question is, I'll ask you a question. What is the type of number 7 and what is the type of number 8? It's a question to you. Both are integers. Both 64 architecture. Hmm. I'm sorry. Someone messaged me is waiting in the lobby, but I couldn't see anybody here in the lobby. Fine. So yeah, sorry for changing the screen. So one of the drawbacks of type inference, what I could see is, uh, it's not the drawback. I don't say drawback. It is the way how type inference. Type inference means you did not tell the type. You're asking the compiler to decide the type. What happened is this is considered as integer and this is also considered as integer. Even though it is a very small number, it would not take it as int 8 or int 16. It is a small number, it is a bigger number. It does. So both of them are considered as int. Again, as you said earlier, as it depends on the architecture type. Generally, when you ask anyone what is the size of int, we always say int is 8 bytes. The reason is we are no longer using any kind of we are using any kind of uh, what do you call 32 sorry 32-bit machines. We are always using 64-bit machines. We no longer using 32-bit machines. Okay, so it is integer and it is also integer. That is the reason whenever I know that my data would not exceed more than 8 bytes, sorry, more than 8 bits, 1 byte, I always specially go and give, let's say I create something called age, where age equal to 42. Okay, I create a variable called age. Let's say here I go and then I put age equal to percentage %t and I put it as age. So whenever I give age, I don't leave it like that because age would not exceed more than 1 byte. Age would not be more than 127. Even if you go for unsigned signed intake, age would not exceed. Okay, but still, if you give like this, it would automatically take 8 bytes. It's very important. It looks pretty silly, but it is not that silly when you go for writing production grade applications. Okay, it is not silly when you go for the production grade applications. 1 minute, I think this man is joined in a separate one. 1 minute. So it is not very silly. Sorry, it is not very. It's very important thing in a production grade applications. It looks pretty silly, but it is not silly basically. The reason is, let's say that you are writing an application something like a Twitter. So assume that age is 8 bytes. But actually, what is the requirement of age? Age is supposed to be only 1 byte. So when you create a age, when there are 100 people join the application or concurrent users, 100 concurrent users are there in the application, there might be only 700 bytes are wasted. But if keep on growing, a million people concurrent users are there in the application, so 7 million bytes are gone waste. 7 million bytes is not a simple thing. 7 billion bytes is nothing but a massive data. It requires a lot of RAM, it requires a lot of memory in order to take care of 7 billion bytes. So it is always good to go and then give proper data type sometimes. Because if you give the inference would always take it as 8 bytes. So my suggestion is particularly with these two, the floating point numbers and normal integers. Numbers, I prefer to give the type of the variable, but Boolean there is no problem. String there is no problem. But with respect to these kind of variables, numbers, it is good practice to give the type so you can give uint 8. If otherwise it would take it as 8 bytes. So this is 8 bytes, this is 8 bytes, this is also 8 bytes. It's not, even though if you give float point where float 4, which is a very small number, okay, even it is a very small number, still it is float 64. Still it is a float 64. If you go to float 3 and then I give it as float 4 and somewhere here float 3, I give it as float 4 percentage maybe F, I directly give. It is still takes as 8 bytes because we did not tell that what kind of floating value it is. You see that's taking 3.14 and some zeros. You may have to control the number of digits. Okay, so it takes according to the number of digits that it can accept. So, but all these variables are int 8 other than this. All these numbers are 8 bytes. All these numbers are 8 bytes other than this. How do you know all these numbers are 8 bytes? You can see the type of the variable fmt.printf, maybe what is that? Number 7, number 8, float 3, numbers type of number 7. You can see percentage %t, type of number 8. You can use percentage %t, type of number float 3, which is percentage %t, comma number 7, number 8, and float 3. I did not personally give, I did not deliberately give this. I'll tell you that. There is another way to get the type of a variable from a package called reflect fmt.println type of float 4. You can also give reflect dot type of reflect is the package reflect dot type of float 4. You can also give like this. Instead of giving this format specifier, you can also use the reflect package in order to know the type. So when you go and then run it, you see that all of the types, number 7 type is integer, number 8 type is integer, type of float 3 is float 64, and all, even though it's a very small number, sorry, type floor is also float 64, even though it is a very small number. So whenever you are working with integers and all, you need to understand that the type of the variable, okay, is very important. The type of the variable is very, very important. The type of the variable is very important. Uh, 1 minute. Okay, type of the variable is very important. I always prefer to to get a proper type of the variable and all. So fine. So coming to this, I hope you understand. There is another way to create a variable which we call it as a shorthand declaration. Shorthand declaration means you don't need to give the type or anything, just give a comma b colon equal to 10 comma 20. A comma b comma c equal to 10 comma 20 comma maybe 13.45. A comma c comma d equal to okay, sorry, boolean true comma e equal to hello world. You can declare variables like this. Just give colon equal to one variable or multiple variables. This is a group of variables. Even you can give, let's say, a equal to 10, like that you can give. A equal to 10, like that you can give. From B onwards, you can create the group of the variables. This is a shorthand declaration. Shorthand declaration means you don't use a keyword called var. You don't use a keyword called var, but you just give the uh, just give the any type directly. You assign a value. You did not here. You used a variable called var. Here you did not use any variable called var. You just give the value to the right side. So a colon equal to 10. You just give the value called 10, and that's all. You didn't give the any kind of the variable. to this particular concept. Okay, okay. Right. Hey, hi, I did not receive any kind of invite, sorry, any kind of alert that you are trying to join the meeting. So this is what happened. And coming to the next one, so you obviously you have to print them. So right now I'm just printing them easily, A, B, C, D, E, not to get any error. So these are just going to print the variables, nothing else. Otherwise, it would give me an error. Just to give some values like this. Fine. So you understand what is the type of the variable, etc. So these are all the ways that you can declare a variable. So you may prefer to use properly var variable type value, or you can give just var variable value type inference. You can create shorthand declaration, just give the variables and then assign a value. It's a very shorthand declaration. One more thing in Go is, for example, I say A1 comma B1 equal to 10 comma 20. I want to swap the variables values. You know that what is the meaning of swapping values? A value in B and B value in A. How do you swap the variables values? I may say that A1 or T1, for example, colon equal to A1. I take a temporary variable, so A1 equal to B1, B1 equal to T1. This is how you can swap the variables. So now B becomes 10 and A becomes, so I say A1 and B1, A1 becomes 20 and then B1 becomes actually 10 because we swap the values. You don't need to do this much in order to swap the values in Go. Okay, I think even in Python, you don't need to do. So you can simply do A1 comma B1 equal to B1 comma A1. This is kind of a swapping. This is not limited only to two values. You can also do with three values, four values, or any number of values. You please try it. Okay, this is simple swapping. Why I'm talking about swapping is a technique that we use very regularly in programming. So whenever you want to do the swapping, you don't need to really create a separate, no need of, again, A1 and B1 would become normal values like 10 and 20 because two times we are swapping. So you see that again they became 10 and 20 because again swapped back. So for swapping, you can simply do the swapping. What do I mean by is A2, B2, C2, A2, B2, and C2. If you have again any question, please do ask me. Yes, here A1 and B1 I created two variables. Created. This is a shorthand declaration. This one. That means created new variables called A1 and B1 with names with values and type as well. Type inference. That means A1 is integer, B1 is integer, A1 value is 10, B1 value is 10. This is called as a shorthand declaration. In the second thing, T1 is again a new variable. T1 is again a new variable. So T1 we give colon equal to because we are creating a new variable. Here we are not creating any new variable, we are reassigning the value to the existing variables. So whenever you create a new variable, let us say that you see that A2, B2, C2. Why I give colon equal to? Because A2, B2, C2 are three new variables. Creating, so this is nothing but where A2 is integer equal to 10, sorry, B2 is integer equal to 20, C2 is integer equal to 30. This is what exactly I am doing. This is what exactly I'm doing. Okay, with the shorthand declaration. Okay, instead of doing this, I am simply doing this. Okay, here also it's a new variable because there is no t1 before that. It's a new variable, so I'm creating a new variable with the value of a1. That means 10 would be stored in t1. So t1 is a new variable, so that left hand side I give colon equal to. So colon equal to is the creating new variable, equal to is assigning a value to the variable. Okay. So when you say, I think I hope you understand, A2, B2, and C2, there are three variables. Even them I can swap easily. I don't know. What do you swap? Let's say B2, C2, A2. I can give A2, B2, C2 equal to B2, B2, A2. Sorry, B2, C2, A2. So what would happen? The B2 value goes to A2, C2 value goes to B2, and A2 value goes to C2. Again, this is a swap of three variables. You can do swapping of any number of variables without any issue in Golang. You don't need to worry that okay, I'm swapping one variable, I'm swapping. No, you can do that as long as you know where you are swapping. So swapping is very easy. Actually, this swapping is quite complicated. You need to bring, it's not complicated, but you need to bring more variables. But in Go, swapping happens. You can also swap directly with the variables and variables by assigning the uh, variables to be swapped to the right hand side. Swapping means as keeping the value one value into other value is value into this variable. A2, B2 value into A2 and A2 value into C2. This is called as a swapping. We did swapping. You don't need to print them here because already we used the variables. So I think we don't need to print. If you want to print, obviously you can print line A2, B2, C2 is going to be, sorry, C2, it is going to be A2, which is called 20, B2, which is called C2 30, and 10. It is going to print 20, 30, and 10. 20, 30, and 10. This is how the variables get swapped. Okay. This is how the variables get swapped. This is called as the swapping the variables. You can do swapping the variables in Golang. Fine. Let me go to the next example rather than writing everything. I think what we discussed is we discussed that we have three types of we have multiple types of variables. We discussed with integers, floating point, boolean, and string. There are a couple of other variables to be discussed. One is called these two. These are not a new variables, they're just existing variables with a different name. And then we also have to discuss about interface. So let's go there. So what I do is I create again stub with three variables. I have a new application which is called variables and all. Now, what about the characters? What about the characters? In order to discuss about the characters, you need to know what characters are in Go. For example, I create str1 equal to, I put it as hello world. I put str2 equal to, let me go and then get the hello world. I take hello world. I take the hello world in the Chinese characters. I put as hello. I don't know what is going to be really, but I just put it as world. There are two strings. So What is so there are a couple of things we need to discuss about strings. Most probably tomorrow's session we will spend more on strings and memory types, where the things would be stored in the memory, what is called data segment, what is called text segment, heap and stack memory. A lot of other things we'll discuss. But as of now, because we are going to discuss about characters, as of now, just confined to the characters. How many characters are there? How many characters are there for the string, for the first string? So we have 1, 2, 3, 4, 5, space is 6, 7, 8, 9, 10, 11. So 11 characters. How many characters are there in the second string? 1, 2, 3, 4, 5, 6, 7, 8. 8 characters. So when you say the length, what is the length of str1 and then what is the length of str2? Length means how many bytes that the characters occupied in the memory. We call it as a length. There are two different things. One is called length and other one is called size. We have to discuss about size later on. Just discuss only about the length. So when you print length of length of str1 equal to, there is a built-in function called length of str1. Length is a built-in function. Print line is a built-in function. There are approximately 18 built-in functions as far as I know. Okay, we will discuss about them. Length of str2 is str2. This is the length. Length means how many bytes. Remember that length is not always how many characters. Length is not going to give how many characters. It gives how many bytes. Length is not going to give how many characters. It gives how many bytes. Okay, how many bytes? So what would happen if you really know the byte calculation? Each character can be 1 to 4 bytes based on the UT of 8 characters. Some characters are 1 byte, some characters are 2, some characters are 3 and 4 as well. Each character depends on the character. Unlike old C language computers, where each character is ASCII character, which is 1 byte. But here, all these are 1 bytes. So when you print it, it prints it as 11 bytes, first one. But even though there are only 8 characters, it has printed as 12 bytes. The reason is these are all 1, 2, 3, 4, 5, 6, 6 characters, 6 bytes, because these are all ASCII characters. And the next two one is 3 plus 3 characters. This Chinese character is 3 characters. Again, the Chinese characters is 3 bytes. Sorry, not 3 characters. 3 bytes. 3 bytes. So 6 plus 6, which is called 12 bytes. You got it. Why do you get 12 bytes? Because the string is collection of characters. In some programming language, what would happen is each character of the string is taken as 4 bytes by default. They don't care whether the character is 1 byte or they care the character is 4 bytes. They always give the character is considered as 4 bytes because they don't follow any kind of UT of 8 or what is the size of UT of 8. They don't care the size of the UT of 8. Rather, they directly take each character as 4 bytes. But in Go, it is not like that. It purely depends on what kind of character it is. If it is fixed into 1 byte, obviously it is 1 byte. If it is 2 bytes, it is 2 bytes. In Chinese characters, 3 bytes. So that is the reason string is always collection of string is always a collection of bytes. We don't say string is collection of characters. It's a very important thing to understand in Go. String is not collection of characters. String is collection of bytes. So string is immutable. Why it is immutable? How the immutability works and all. We will discuss about that in the following session. For now, I would just would like to keep it strings limited to this. Again, coming to the character. What is a character in Go? What is a character in Go? Go doesn't have any character type. You don't have something like, okay, where char1 is char. You don't have that. Go does not treat any character as a string or, the character. Rather, Go treats every character as just an integer. It is a value. It's a value. It takes the what do you call UT of 8 sequence value, UT of 8 value. For example, you take where char1 equal to uint 8 equal to colon a. It looks pretty surprising for you. What is the value of a? What is the ASCII value of a? The ASCII value of a is 90, 65, 66, 65. The ASCII of a value is 65. So 65 is within the limits of uint 8 so that you can give this. But you cannot do the same thing where character 2 is uint 8 equal to this one. Go compiler is capable of understanding because it's everything happens at a compiler. Compiler thinks that, yeah, what we think is A is a character and the Chinese character is also a character. But how can it accept A but not accepted the Chinese character? Because it is within the limits of 255 because I give uint 8, 255 less than or equal to 255, so it can accept. But this is not less than or equal to 255. It might be 19,990. This one. This is the value. So what it accepts is if it is uint 16, I think it accepts. But uint 8 it doesn't accept. Let's go to even bigger character. Let me take it as var character 3 equal to directly I can give okay uint 32 equal to let's say some I take a hard UT of character. Okay, let me copy this character. It's not taking this character by it is a UT of 8 character. No, still it is illegal. Okay, there might be copy paste error. It's not accepting directly, but you see that this is generally 4 bytes. It's a 4-byte character. If you want to put it into int16, it doesn't work out. Let me go here. Or UT of character. Let me go from here and copy rather than copying from there. Okay. If you take this character, actually this is 4-byte characters. You cannot give it as 2 bytes. So if you print line char1 Char 2, char 3, Go doesn't understand these are characters, even though you give the values as characters. Go always think that these are all the values. These are all the values. So Go obviously print only the values. Go doesn't know that these are characters. You see 65, 19,990, maybe even bigger one. These are all, Go thinks that these are all values. Go never treat any character as a character, even it is inside the string. For us, it looks like a string, but obviously Go thinks that these are all the ASCII values. These are all the ASCII values of that. These are all actually ASCII values of the string. Depends on the value, depends on the character. It can understand whether it is falls into 1 byte, 2 byte, 3 or 4 byte. It can form those number of bytes. So in order to mitigate this particular solution, Go come up with a, a type called room. Why do you, what is there to mitigate? Because if I take it as a character, for me, A is a character, Chinese character is a character, the heart symbol is also a character. Emoji it is called, it's also a character. But I cannot deal with them in three different variables, even though it is how it is. But I don't want to deal with them as three different variables. I don't want to deal like that. I just want to deal all the characters, three characters in the same way. So there is no special type called Rune, but what Go did is Go took a variable called int32 and then they renamed it. They create alias called Rune. We call it as alias. Alias means it is not a new variable. Let's say where character 4 is Rune equal to A, capital A, get me you. Character 4 equal to the Chinese character. Character 4 equal to the another character. You just print character 4. So what would happen? What is called Rune? Rune is nothing but int32. There is absolutely no difference between int32 and Rune. There is absolutely no difference between, because Rune is nothing but an alias for int32. Alias means a different name for int32. Why they give the name? Just for the convention purpose. Rune is not a new data type. New Rune is not a different data type like we are using something like int 8, int 13, int 16, sorry, int 16, int 64, int 32, like that. Rune is not a different data type. Rune is a data type which is nothing but int 32. So even you create a Rune, it doesn't mean that it is going to print you in a character format. Even you create a Rune, because Rune is not a character, basically. There is no character type in Go. Rune is not a character. Rune is still a nothing but integer. If you want me to print the type of this particular variable, print line, type of character, type of character 4, I can give something called reflector dot type of character 4. So you get to know that, sorry, let me give fmt dot print line. You get to know that int 32, nowhere you get it as, I'm sorry, nowhere you get it as, nowhere you get it as integer. Sorry, Rune. You always get it as integer because int32 and rune are same type. There is no difference between. Yeah. So there is no type called rune. There is no type called there is no type called rune. Rune is nothing but integer int32. There is no differentiation between the rune and int32. Rune is nothing but int32. So many of us think that rune is a separate type. It's not. It is just an alias for the existing. You can also create your own alias. Let's say that type character equal to int32. This is called as alias. Alias is not a new type. Alias is a new name, another name for the existing type. So you can also create where uh, let's say char5 is character equal to this one. What is char5? Char5 is nothing but int32. Same thing they have done for the rune as well. If you even go to the code, so built-in package, you see that type rune equal to int32, type byte equal to uint8. So both of them are same. Type any equal to interface. These three, I think only these three are like that. These three. There is no separate type called byte. They just take unsigned one byte int 8 because byte is nothing but 8 bits. They take unsigned 8 bits and they call it as byte. You can use this or you can use this. There is no type called room, but convention purpose. Convention means how do they distinguish between a character and a number? There is no type called character in Go. So how do they distinguish? They distinguish by calling it as a rune, but actually you can do like this, you can do like this. Both of them are same. You see that. I take rune, I give A, I give Chinese character and I give this. Even you can take like integer 32 and then you can assign these three because however it would not exceed more than 4 bytes. 4 bytes is the maximum limit for a Unicode UT of 8 characters. So that's the reason even do when I do the reflection, even do when I do the reflection, it always print as. So let us do the same thing with character file. In fact, it prints only as int32. It doesn't even rune prints int32. Character 5, which is called char, which was also print as int32. The reason is there is no sub differentiation with respect to the Go compiler between int32, rune, or even you create a new character. Even you create a new character. Instead of let's say that I give where age is uint8 equal to 42. You can also give where vh is byte equal to 42. There is no difference. Both of them are same. We call it as a byte because whenever you want to send the data like streams and treat the data as bytes. But there is no byte with respect to Go. Byte is just a name that it has used. Okay, you can also create. Okay, you can also create a type called type single equal to uint8. So instead of byte, you can also single. You can also single. Let's say where okay s byte is single equal to 42. So all three of them are same. There is no difference. Even if you put any of the type bh, bh, s byte, okay, all three of them are same with respect to Go compiler. But just for our convention purpose, you are streaming the data. If you are streaming the data, you call it as byte. If you're uh, dealing with each and every character inside the string, it comes in the form of bytes. Byte array. Byte array is nothing but this is going to be a byte array. Whenever you string, it's going to be a byte array. It's going to be a byte array. Why? Because This one is 6 bytes and this one are 6 bytes. So altogether 12 bytes are given to you, which is called byte array. We will see that in the next session. We will see all these things. In general, I'm speaking. Okay, even if you print line, fmt.println, okay, type of age is got to be reflect dot type of age, type of bh is nothing but reflect dot type of bh. Similarly, you can have type of sbyte is nothing but reflect dot type of sbyte. When you print it, all of them you get same, which is called uint 8, uint 8, uint 8, and uint 8. Why? The names are different, but the underlining type is same, which is called byte, which is called, sorry, uint 8. So it is just an illusion for us. Rune is a type, byte is a type. Actually, there is no type called rune. It is always about uint 32. Even if you want to deal with the characters, you can also deal with characters with the numbers, uint 8, uint 16, or int 8, int 16, or all the number types other than floats by giving in a single quotation. Single quotation is treated as a character, but Go always think them as Unicode UTF-8 values. Some of them are ASCII sequence values from 0 to 254. Obviously, they are ASCII values. And from then onwards, it could be 2 bytes, 3 byte, and 4 byte. So can be any character can be fit into 1 to 4 bytes. Obviously, 1 to 4 bytes if a character can be fit into. So any one of 1 to 4 bytes of the character. That's all. There is no difference between something called a character, something called a byte in Go. So that is what actually for today uh, we will we will discuss about the much more important concept where this data is stored, what are different segments, how the strings are formed, and we also discuss about any type. A string is immutable, why it is. If you create a string, where exactly the string is stored, how these kind of internal details are required to be known, then only you can really do some kind of critical programming in Go. We will discuss about all these things. Uh, any questions you have, please do ask me. Yeah. ASCII or not ASCII character. ASCII means only 0 to 255. Yeah, Unicode character, UTF. Above 8. It could be 8 or it could be more than above 8. Because Unicode characters also include the ASCII characters. Yes, you can think of 1 to 4 bytes. Yeah, that's it. That's That's it. That's it. There is no difference. Even in fact, there is no type called rune. First of all, if someone asks you what is rune, you say that there is no type called rune. It is just an alias, another name for int 32. That's all. Okay. Technically, there is nothing called rune in Go. Rune is just a name for our convenience. They have created for the developer's convenience. But technically, there is no data type called rune in Go. It is just int 32. That's all. Okay. Yeah. So don't worry if you don't understand. Okay. We will go through one after the other. So if I directly jump, you asked a question, what is called rune, right? I did not explain because unless until I explain this way, if I directly explain that, you may not be able to grasp it that easily. So for that, I need to explain what characters belongs to int 8, what characters belongs to int 16, something like that, and then ultimately I have to slowly take you to what is called room, why Rune is not a character, that kind of a thing. Okay, that's how the I prefer to explain that. That way you can understand very easily, rather than directly jumping to the Rune and explain. Okay, this is called Rune or something like that. Okay, so that's all. I think that's all. Let's meet tomorrow. Again, I told you this is the steep learning. Uh, if you want, you go ahead and then watch the other videos as well, where you can have the fast-paced learning you want to prefer. You can always do that. This learning is kind of a steep learning. We go concept by concept, an hour and a half every day, and then go through that. Okay. If you want quick, we can also have the couple of more hour sessions on Saturdays, maybe 2, 3 hours or even 4 hour sessions. I don't mind. uh, we can plan for that as well. People who can follow, they can follow. If you occupied, they can go through the maybe recordings and can do that as well. But I'm just telling you. Okay, that's all for now. Let's meet tomorrow and then take the session further. Thank you very much.